Hey there! So last time we prepared our local development environment. We installed Git and VS Code with some add-ons. And we also have those remote repositories prepared. But actually, we didn't even start working with the code. So the plan for today is to clone the remote repository to our local machine, make some changes, and finally push them back to the remote repo. So let's get started. Alright, so today we'll finally start writing the code, making some changes. And please remember that those videos, at least for now, they show the happy scenario, the simple path, right? So we'll not focus on some possible scenarios or edge cases that might happen. We'll cover that in the future. For now, let's get things working. Alright, so let me switch to my virtual machine that represents the environment for our user one that is granted access to our repositories. And you should remember that we have repos, remote repos created in two platforms. One is in Azure DevOps and the other one is in GitHub. And I will today show how to work with two of them. And please remember that they represent two separate projects. Maybe one of them holds our front end and the other one holds the backend code of our application. It is not the same project that is stored into remote repositories, as it wouldn't have much sense. And actually, in real life, you would probably work with a single repository, single remote platform only. But because I want to show you how to work with both of them, that's why I have such setup. Alright, so on this virtual machine. So first of all, we don't have this remote repository available locally yet. So the first thing I want to do is to create a directory on my local environment where we will store the source code. And I will simply go to C drive. Here let's create a new directory called repos, or however you want to call it in your projects. And then let me create two separate directories, one for Azure DevOps and one for GitHub. So let me call it Azure DevOps. And here we'll store the code cloned from ADO. And the other one would be for GitHub. Like so. So the structure is available, but it is empty right now. So now, how do we make sure that the code that is available remotely can be downloaded locally? And to do this, we'll use a clone command, which simply clones code from the remote repo to our local environment. And I will start with Azure DevOps. Later on, I will do something similar with GitHub. So I'm in Azure DevOps and I'm in my solution A repository. That's the repo that we want to clone. And here on the right hand side, you see this clone option. And if I click on this, you'll see some options that you could use to clone this repo. Some that includes command line that we'll skip for now, and some that uses some IDE like VS Code. And you should remember that yes, we won't use VS Code in this exercise. So let's clone the repository directly in VS Code. So let's simply click this button, clone in VS Code. And yes, let me allow on this website to open a VS Code. And it should open in a second. And immediately it will start to clone the repo. And there it is. So we've got this new window opened that asks me, alright, so where do you want to clone this remote repo? Where on your local disk drive you would like it to be stored? And we've just created this directory. It was C repos Azure DevOps. So that's the directory where it will be cloned into. So yes, please, let's do this. and I'm assuming that this user one has all necessary permissions to connect to this remote repository, and it does. It asks me to log in, just to make sure. And yes, it has been cloned. And it asks me, actually VS Code asks me if I would like to open the repository that we've just cloned. And yes, please do this. So it was opened in VS Code. And now, because it's the first time we are working with this folder, it asks me if I trust the authors of this folder. And yeah, I do trust it. So yes, let me select the checkbox, and yes, confirm. So I would be able to work with all the files from this repo without any restrictions. Alright, so we did something, right? We cloned the repository. Let me actually go back to the File Explorer. And inside this Azure DevOps, we can see a directory called Solution A. That's the name of our repository. And if I go into it, you can see a directory called documentation that should contain a single file, this intro.txt. And why do we have this documentation and directory in this file? Simply because that's what we have in our repository that we just cloned, right? We have this documentation with intro.txt. So that's how we made the remote repo available locally. So you can finally start working on it in VS Code. But before we go there, let me actually draw it what we did, so it would be easier to understand. Alright, so what we have is as follows. So we've got remote repository, and by remote repository, I mean those platforms like GitHub, GitLab, Azure DevOps, Bitbucket, and so on. So for example, we've got Azure DevOps or GitHub. So that's one part of our solution. Apart from that, we've got our local environment, our local machine, my laptop, on which I'm working. So actually, let me draw a line between those two. And we've got my local environment, my local machine. Local machine. Actually, let me draw it like this. Alright. But the thing is that within our local machine, there are two things that I would like to make you aware of. So let me split the local machine into two areas. So actually, let it be this way. Alright, so within my local machine, we've got two things. The first of all, we've got a working directory that in a second I'll explain what I mean by this. So this is working directory. And apart from that, we've got a local version of our repository. So this is our local repo. All right, and let me just draw it like this. So first of all, what I mean by working directory. So let me switch back to our VM. So working directory is simply this. This is our directory where we cloned our repository. So this is it, the contents of it. Right now it's pretty empty, it only has this documentation directory, but as we will progress with our work, we'll have more and more items available here. So this is our working directory that represents the stuff we are working on in repo, right? That's the first thing. So it is this part from the diagram that is available on my local machine. Remote repository, that's pretty obvious, right? That's the stuff that we have in GitHub, in Bitbucket, in Azure DevOps, and so on. So the last part is this local repo. So what is this? And you should remember that I told you that Git is a distributed source control system, and every developer will have its own copy of the repository. So it has to be stored somewhere. And this somewhere is exactly this local repo. So where is it? So if we go into Azure DevOps directory, that's where we cloned the repo into. And actually, let me show hidden files in this place. So I will do this by using this show hidden files option. Oh, come on. Is it here? Yeah, is it here? So you should see this hidden.git directory. That's something that is managed internally by Git. And actually, if we go into this directory, it has this strange structure that you should not be even touching. You shouldn't be even looking at it. But basically, that's where Git stores the local repository in this hidden directory. So that's the place how it manages the repo under the hood. But now it is hidden for a reason, right? This .git directory, because you are not expected to go there. You are not expected to work with those files directly. No. So let me hide it again. So let me change the options again to don't show those hidden files. So we no longer see this hidden.git directory, but it is there. And we'll interact with this local repository by using either git commands or some UI like in VS Code, right? So local repo is simply this hidden.git directory that is available locally. So let's now see what exactly this clone command did when we run it. So actually, let me add a nice table layout. So we had some files here in a remote repository. And what we did was to run clone command in VS Code. And clone basically took the stuff from the remote repository and it put them into the local repo on my local machine. Apart from that, it also set the working directory with the contents of our remote repo in a human-friendly way. So instead of this strange internal structure that is used here in local repo, we see in working directory just nice folders and files. The same stuff that we see in a remote repository. So that's what we did. That's what clone does. It grabs the current state of the remote repo and it clones it locally. Now, important thing about this clone command is that it is to be run only once within the life cycle of the whole project. So basically you would run it only when you've never run it yet, when you don't have this local repo available yet, and you just want to initialize your project locally. Later on, you would do different commands. So please remember this. So this is one-time action, right? Don't run clone multiple times because there's no reason to do this. So that's what clone did. Also, Git was smart enough that when we run this clone command, it made those internal links between our local repository and remote one. So if in the future we would like to pull changes from remote repo, so this way, because maybe our colleague made some changes in the code and you would like to have them available locally, Git would know how to link this remote repository with our local version. So it will be able to update a proper directories on our local machine. Likewise, if you would like to later send our changes to the remote repository, and we'll do this today, so it would be this direction, Git would know how to do this properly, how to link our local environment with remote repository. And it is done under the hood. At this moment, all you need to know is that it is handled. It can be modified in the future, but it is more advanced scenario that we can ignore for now. All right, so we have the code available locally. Cool. So let's get back to VS Code and see what we have inside. So first of all, if you've never worked with VS Code, let me give you a quick tour of the most important areas. So the first one is here, the Explorer, this icon. And it simply, if I click on it, it simply shows the contents of a folder that is opened right now in VS Code. And actually, right now it is opened with the contents of our solution A. So it shows only this documentation directory, which inside has this intro.txt file with this will be the best project ever text, right? And it is opened in this way because when we cloned the directory, VS Code asked us if you would like to open it. But you can do the same by using the file and then using open folder directory and then choosing some folder like so. So you can easily switch this the stuff that you are working on, this directory. So that's first thing. Secondly, at the bottom, you can see that we are on a branch called master. And this is important. But branch, what is branch? What's the reason of this? So let me explain the concept of branches, which is very important in Git. So pay attention, guys. So basically, one of the design goals when creating Git was to allow developers to work independently on multiple features, multiple bug fixes, multiple changes at the same time without interrupting each other. And that's what branches can be used for. So actually, let me draw it. So let's imagine that we've got our source code that is being developed over time. So let's say this is how time progresses from left to right. And let's say that we've got a version 1 of our code. This C1, it represents the first change that was done. Then after some time, some developer, maybe you, maybe me, we made a second change, C2, and the code evolves, it changes. We are adding new features, maybe some bug fixes, or some, I don't know, maybe documentation, or whatever. Let's say we've got yet another change, C3, and then you decide, all right, so I was assigned a given task that I have to work on. But actually, I would like to work on it in isolation, without being impacted by all the other changes that my colleague might add in the meantime. So if my code doesn't work, it will be my fault and not the impact of some other change. And it also works the other way around. So my changes that might not be finished yet, might not be ready to be deployed, they will not affect anyone else, right? So what I would do in such case would be to create a branch for my changes. And simply put, branch is a separate path of our history of our code that at some point forks from the original path. So in this case, let me mark it in blue. So I would create this blue branch for myself, for some feature, for some new functionality. And I would make a change called C4. So at this time, we've got two separate branches. The original one, that was the base of our solution. And this original branch is very often called master or main. It depends how it was configured in your source control. So we've got this master or main branch. And right now I started a new isolated history of changes, my branch, this blue one. And within my blue branch, I'm developing some changes. So maybe I added change 5, C5. So my branch, this blue one, it contains those changes made by me directly, and also it contains all the stuff that was available at the time when I created my branch, right? So basically I inherited all this stuff. Now, at the time when I'm working with my branch, maybe someone else is working directly with this master branch. So maybe someone created yet another change, C6. But the cool thing is that in my branch, I don't see this C6 change, unless I explicitly ask Git to make it available here. But at this moment, I don't want to do this. I want to work in isolation without being impacted by anything else. And that's what branch is. Let's say that my other colleague would like to work on a bug fix that was found in our code. Unfortunately, that's how life is. So he created yet another branch, green one, this time from this moment of time, so from a different code version that I did. And let's say he made a change called C7. Then he made yet another change, C8, right? Then maybe for some reason, some other colleague decided, hey, actually, I want to create yet another branch for my development purposes. Maybe I want to experiment with some feature, but actually, I don't want to start from this point. I want to start with this from this point because it contains the hotfix. So what this person would do would be to create yet another branch, this purple one, and make a change called C9. At the same time, other colleague would make a change C10 and so on. So as you can see, branches that here I represented using different colors, they allow us to work independently, work in isolation, right? We've got 4 branches at this moment. Now, obviously, later on, when we are happy with our changes, we would like to bring them back into the main version of our code, but that's something that we'll cover in the future. For now, please remember that branches are used very frequently when working with Git. And it is very easy to create them. They are pretty lightweight, so it is fine to create multiple branches. Git was created with this design goal in mind. Now, there are different branching strategies defined that you could use, and branching strategy basically means how you interact with Git, how and when you create branches, and if there are any that have any special meaning. For example, branch called production might represent the state of the code that is deployed to production. And every team can adopt its own branching strategy. There are some well-known and well-defined that are widely used. And I will cover the most common ones in the future. Please just make sure that in your work you ask around, hey guys, what's the branching strategy we use? And then follow it. Here, in our case, we'll start simple. So basically, I will assume that for every change I want to introduce, and yes, we want to make some changes, I will just create a new branch on my local environment. And that's what we'll do. And the final thing is this master and main branch. So are they special in any way? No, it's just a name of the branch that is a default one that is created at the time you initialize a repository. But actually its meaning, it depends on how you treat them, what branching strategy you use. So it all depends on your company, on your team. So let's hop back to our VS Code. So this thing here at the bottom, it shows that right now we are in VS Code working on the master branch, right? And we know that we want to create our own. So let me draw what we'll do. And it will look very similarly to what we had above. So we've got, in our case, it was it is called master branch. So we've got a master branch that has already some changes, maybe C1. And this C1, maybe that was my initial change when I created this documentation directory and added this intro.txt file. So what I will do in a second would be to create our own feature branch for my changes. And those side branches, they are very often called feature branches, just to indicate that they are created to work on some feature, on some functionality. And within this feature branch, we'll make some changes. So, for example, I will make a change where we'll add a new file with some comment. Or maybe we will modify the contents of an existing file. So let's do this. So first of all, how to create a new branch. And we'll do this on our local environment, on our local repository. So to work with source control in VS Code, let's switch to this option, which is called, well, source control. And here, if I hover on these three dots, more actions, I can create a new branch. So I would choose this branch and then create branch from option. That tells Git, hey, I would like to create a brand new branch based on some other branch. And in my case, we'll create it based on our master branch. So one more time. Branch, create branch from. And yes, please create it based on our master branch. Oh, come on. One more time. Branch, create branch from master. And please give a name to our branch. And again, that's something that should be defined within your team, how you name your branches. What I personally like to do is to use this feature prefix and then some ID from our task board that represents the task I'm working on. Add new files or whatever my task is called. And please note, actually let me hide the stuff that I don't want you to focus on at this moment. Please note that our branch indicator changed from the master branch to this feature something, right? So it indicates that we are working now on this on this specific feature branch. So let me go back to our file explorer, and let's simply add, actually let's modify our intro.txt file. I added some cool docs here. And now let me save the file, save the contents. And let's add new directory, but not in here, but in, oh, come on. Let's call it code. So we've got a code. We've got a folder for documentation and a folder for code. And inside code, let's add yet another subdirectory. Maybe let's call it frontend. And here let's add a file like code.txt. This is my frontend. And again, let me save it. All right. So what happened at this moment? I created a new file, a new directory, this frontend stuff, and I updated this intro.txt. And actually, you can see those files in our directory using Windows Explorer, right? Because this is just the way we interact with file. We work with it through VS Code. The same would work in the same way if we just created a new file here, like another txt. It is visible here as well. So it doesn't really matter how you interact with your working directory. You can do it directly through here if you want, but that's why we have editors like VS Code to make it easier. So basically, what I do is to work through this place. All right. So we saved those files. We made some changes. So does it mean that those changes are available in the repository already? No. And they are not available neither in the remote repository in GitHub or in Azure DevOps, and they are also not available in our local repository. Because what we did so far was to only save the files, save the content of the file, but the Git is not yet tracking the changes that we did. So what we did here was to just save those files. So they are saved physically on disk. But what if you would like to persist them in the repository? How to do this? And well, that's what commit command is used for. So that's yet another important aspect of Git, how to save your changes. And the way to do this is to use a commit command. And actually, let me explain what commit does. It's in our table. So whenever we made some changes in our working directory, and that's what we did, and we would like to save them to our local repository, we would use a commit command. So that's what we'll do in a second. So let's say we've got some file and you want to save it in our repository. That's what commit does. And once those changes are committed, they are tracked and they are versioned in our local repository. So later on we can compare changes, we can revert to those stuff that we made, and you can benefit of all functionalities that Git gives us. And now you can think of commit like of save games in PC games. So basically, at various point in time, you would save your state, your game progress. So later on, if something bad happens, you can go back to your save game. commit in Git does exactly the same thing. And just like in computer games, if you have multiple save games, all you can do is to load a state to a specific save game only, not to a state between separate save games. The same in Git. So please have that in mind and adjust the frequency of your commits to meet your requirements. Personally, I commit very often, multiple times a day, but it's your preference. For sure, I would not advise you to commit once a month. It's too rarely. Secondly, please remember that if you want your code to be tracked and versioned in repository in Git, you have to commit it. So you have to make this explicit ask to Git, hey, dear Git, these are my changes. Please start versioning them. Please include them in the repo. So that's what we'll do. So let's create a commit. So let me go back to source control in VS Code and actually take a look. VS Code detected that, hey, we made 3 changes. So in this intro.txt file, we modified it. We just added some this line, right, which is also highlighted by using this green indication. Then we added this front-end code.txt, and you can see that yes, actually this stuff on the right has been added. So this is the new state, and that's the old state that the file didn't exist. And we also added this another txt file. And basically what we would like to do right now is to commit those 3 changes to the repository. So let me provide a message of our commit. So something that is meaningful, because later on, when we'll be revisiting the history or watching the history of changes we made in the repo, we will see every commit. So adding meaningful message would make your lives easier if you would like to understand what happened at the various commits. In my case, let's give it some dummy name like my first commit. And let's just click commit. And now what VS Code detected right now is that, hey, do you want to commit all the changes that you did? And for now, yes, let's do it this way. There is a functionality in Git available that allows us to commit only a subset of changes. But for now, let's commit all those 3 changes. So that's why I would choose yes option. If I would like this message to disappear in the future, I would choose always. But for now, let's just go with yes. And actually something failed. And Git complained that username and user email in Git is not set. And that's true. That's something I forgot to do during the initial setup. So basically, when we are making changes, when we are committing changes to Git, to the history, Git wants to know who made those changes, who should be tracked in the history. And it does this by using this username and user email properties. So actually, let me configure this. And to make this work, I will simply use a git cmd, git command line that was installed together with Git. And here, actually, I would use 2 commands. So git config this, I want to configure my Git, and I want to set this property username to me, to username. So user1 would be displayed as a author of commits made from this machine. Yes, please. And the second configuration I want to make is something similar, but for user email that I want to set to my email. So again, it will be also available in Git history. Now, if I would like to verify if those changes were recorded, I would use this git config -- global list property. Oh, come on. Let me check how it is done. All right. So I forgot to remove this global stuff. So the proper command is as follows: git config list. It shows the configuration of Git. And you should see at the bottom those two fields that we've just added, username and user email. So having done this, it should work this time. The commit should work just fine. So let's try to do this one more time. Yes, please commit all those changes. And this time we didn't have an error message. So something was done, right? Those changes disappeared from the list. And basically they are now stored in the repository. So those 3 changes we did are tracked, but only in our local repository at this moment. So let's revisit our diagram. We did the commit, so those changes are available here in our local repo, but not yet in Azure DevOps. But that's fine. For now, we want to work locally, and we'll push them to remote repository at the time when we are happy with the changes we did. All right, so let's make some other changes. So actually, let me decide that actually we don't want to have this another txt file. So let me remove it. Yes, please. And in the code, let's add some changes, some other changes. Like so. Let me save it. Save all. And in the changes list again, Git detected that we want to remove this another txt file, and we've got some update in our code txt. So let's commit it. My second commit. And obviously this commit message is not perfect, but for now, let's go with it. And yes, please commit it. So my second change has been made. So basically what we've been doing is this. We made some changes, right? So we made this commit within which we added this file, we modified some other file, and later on we made yet another change, yet another commit. So let me call it C3. And here what we did was to simply remove the file and modify some other one. And all of this is committed to the repo, so it is available there. So please note that in our working directory, we no longer have this additional txt file that we just removed, because we removed it, but it is still available here in this version, in the C2 version of our code. And later on, when we'll be jumping from the history, you will see that this file will be magically available again, because at this point in time, it was available, together with all the changes that existed at this particular time. All right, great. But the thing is that, well, those changes are available only in my local repository. And let's say that I tested all this stuff, it works, it is fine, and I would like to share my code with my colleagues so they could see it. And the way to do this is to push it to our remote repository. And that's exactly what we'll do in a second. And to accomplish this, we would use yet another command called push. And push does exactly this. It grabs the code from your local repository, so from here, and it pushes it to the remote repo, to a specific branch, the one that you have configured. All right, so let's go back to our VS Code and let's push my changes. And please remember that we are on our feature branch as indicated by this field here. So to push my changes, I would go to, well, push option. Let's click it. And what Git detected is that, hey, actually this branch that I'm working on right now, it doesn't have a corresponding branch in the remote repository. And would you like me to create it for you? And yes, it is correct, because we created this branch locally in VS Code. And when we are pushing the code from my local branch, from my local repo to the remote one, Git has to make sure that there is a part in the remote repo that corresponds to my local environment. So yes, please create this remote branch that would have the same name. And it did it. So what we should see in the remote repo, oh, actually, where is the remote repo? Remote repo is here. So this is our Azure DevOps. That is right now showing our master branch. If I refresh this, we don't see our changes yet because they are not available in the master branch. Because what we did was to push them to this feature 123 branch. And if I switch the UI to this branch, I can see those changes that I did. So this additional code directory and this additional text added to my documentation. So that's the proof that my changes are available in the remote repository in this feature 123 branch. So that's what we did. So we were able to push changes from my local repository to the remote one. So if there were other team members working on the same feature together with me that would use the same branch, this one, oh come on, this one, they would see those changes that I did. So they would be able to pull them, but we'll get back to this later. All right, and basically that's what I wanted to show you today. That's the scenario in Azure DevOps. So let's quickly do the same in GitHub. But actually, let's change it a bit, just to show you that there are multiple ways you can work with Git, and many of them will give you the same effect. And now, I switched to GitHub, and here I have this Git Basics repository. And please remember that this is a completely different project from the one that we've been working on right now. Let's say this is our backend that has a separate repo. For some reason, we use two different platforms to host frontend and backend. And let's say that in case of GitHub, I would like to create a branch, my feature branch, here directly on the remote repository. Is it possible? Yeah, sure. It doesn't really matter if you create a branch in your local repository and then you create it in the remote one during the push command, or if you create the branch in the repo and then you clone it or pull it to your local environment. So actually, let me create a new branch in GitHub. So let's give it a name, feature ID, I don't know, 456 backend stuff. And it will be based on the latest version of the code that is available in the main branch. In the future, we'll take a closer look at branches, what they really are from technical point of view. For now, just think of them logically, that there are ways to separate or to isolate your code into versions that can be worked on independently. Alright, so I created a new branch in my remote repository by using a web browser. And this branch, well, it exists only in the remote repository, not yet on my local machine. Actually, on my local machine, we don't have this repo yet, because we didn't clone it yet. So how to clone it? And again, well, let's clone it, but using a different method than previously. So I would go to the code option, and here you can see different ways to clone your repository. And I would use this HTTPS method. And I will use a command line, just to show you that you don't have to use VS Code if you don't have to. So let me copy this path, and basically that's the path to my repository. Let me open this Git command line. Let's go to a directory where I would like to clone this repository into. And it was, I believe, repos and then GitHub. GitHub, yes, it is empty at this moment. And to clone it, I would use a git clone command and then paste this copied text, copied address of my repository by right-clicking in the command line, like so. And at this moment, it is trying to clone my repo. And obviously I have to authenticate. And it should work without any issues because I was already logged in through a browser. And yes, we can see in the message that the repo has been cloned, so it is available locally. So if I go to repos on my file explorer in GitHub, yes, we can see this Git Basics repo with some documentation directory, a separate project. And again, it has this hidden Git directory that Git uses internally to store the local version of the repository. And basically from this moment, it would work locally on this repo in exactly the same way as you did with the repo cloned from Azure DevOps. Basically, it doesn't really matter what was the source, right? So let me switch in VS Code to this repo, to this folder. So I would use file, open a folder, and let me switch to GitHub. And yes, I trust the authors. And we've got this intro.txt file. So what I would do, I would modify it. This is the perfect documentation. Let me save it by Ctrl S. And finally, I would like to commit this change in my local repository. So what I would do, I would make a commit. My commit with documentation. And let's commit it. Yes, I would like to commit all the changes that I have. Cool. What else I would like to do would be, let's say, maybe I would like to add a new directory for code. And here we would have frontend, right? Or backend. I don't remember what we did, what we used in the previous case. Let's say it is frontend. And here we would add my code, takes the file. This is my frontend stuff. And I think that actually we used frontend in Azure DevOps, so we'll change this in a second. So let me commit this. Yes, please. And actually, let's remove something. Let's delete this. Yes, let's remove frontend and let's add backend directory. And let's add the code. This is my code. All right. And let's commit it. Added proper version of the code. And let me commit this. But please note what I did. I forgot to switch branch, and all the changes I did was made on the main branch. And please note that in the File Explorer in Windows, we can see this code directory available because, well, I was working on the main branch, and this working directory, it shows the content of my current branch. But what if I would like to actually switch to the branch, the feature branch that I created in the remote repo? So I would go to source control here and use checkout to option that I want to switch to some other branch. And it would be this feature ID backend stuff. And please note what happened. Let me close those windows. We no longer see this code directory because in this branch it doesn't exist. Please also note what it did to my working directory that we see in a File Explorer. It also does not contain this code directory because it doesn't exist in this version. But if I switch back to the main branch, and in GitHub, actually it is called main, it was master in Azure DevOps, this directory would be visible again. So actually you can do this. So check out again to the main branch. And yes, this directory is visible. So you can see in both places it is there. So those changes are not lost. They are recorded in the repository and they are saved. They are versioned. We can compare them, we can track them. And when we switch branches, we just load the state of our code that is available in a specific branch. All right, and basically that's enough for today. In the future, we'll continue with making those changes. But to summarize, so what we did today. So we had this local environment prepared with remote repositories. And what we did was to clone the remote repository locally. So the code was available on my local environment. And actually at this moment, I could even unplug the internet and I would be able to work with the source code because everything was available locally. Then we created a branch on which we made our changes, and it can be done either in local repository, like we did in the case of Azure DevOps, or in the remote repo, like we did for GitHub. Then within this branch, we made some changes, except for a GitHub version when I forgot to switch the branch. And once we are happy with those changes, we committed them, which made them saved in the repository. They became tracked. And finally, what we did was to push those changes from our local environment to the remote repository. So those changes were made available in GitHub or in Azure DevOps. And that's it for today. Thanks for watching and take care. See you soon.